Hey everyone, welcome to my channel. In this video, we are going to learn how to create a virtual image drag and drop system. We will learn how to import JPG as well as PNG images with transparency and move them around with our hands. We will do this step by step so it is easy to follow and beginner friendly. If you would like to level up your computer vision skills, do check out our premium courses. For the first time ever, we have a computer vision with Arduino course available now for pre-order. The links are in the description below. So without further ado, let's get started. So here we are in our Python project. This is a new project that we have created by the name Virtual Drag Images. Now the idea is that we are going to add images instead of rectangles that we did in the previous video. So we will be able to drag images, whether it be JPGs or PNGs. So I have two folders here. One is images JPG, and you can see that it does not have a transparent background. And the images in the PNG, they have a transparent background. So it doesn't matter whether it is JPG or PNG, we will be able to import both of them. And if it is PNG, it will remove the background. It will just take the actual image and overlay it on our main image. So that will be very interesting to see how we can drag and drop. And later on, probably we can make a game out of this, especially with the PNG images. It will be very interesting to play. So this is our main file. We are going to remove everything from here. Now the first thing we will do is go to File, Settings, and the Python interpreter, and we are going to add the CVZone package. So now here I am seeing that a lot of you are having some issues. So in our previous video, we were using version 1.4. Version 1.4 has the find position function for the hand tracking module. After version 1.5, we do not have that find position function. So if you are following a previous tutorial and you face that error of find position, then don't use the latest version 1.5 and above. Use 1.4 or whatever is shown in the video. So the best practice is, if you want to follow along the tutorial exactly as it is, follow the exact same versions. And in most of my tutorials, I use Python 3.7.6. So, and CVZone here is 1.5, and you will hit install. I have already done that. And then we are at media pipe, and with media pipe, we are at 0.8.72. So again, media pipe is also changing quite rapidly their versions, and there are some errors that I've seen that a lot of you are facing. So let me know in the comments below if you are facing any of those errors. And again, if you are facing errors, go back to the version that I've used in the video. If it works fine in the video, it should work fine for you as well. Most of the time, it's just versions. So we have installed this, and it will have some dependencies, especially the OpenCV, Python, and the contrib, and all of these will be installed with them. So this is already installed. So the first thing we will do is to run our webcam. So we will import CV2, and then we are going to write here cap is equals to CV2.video capture, and we are going to write ID number. I can't remember. I think ID number 2. I have like 3-4 cameras attached, so I think it is number 2. If it's not, we can change. So cap.set at position 3, which is the width, we want 1280. We are doing this because we need more space to move around and to drag our objects, which are the images. So that's why we are increasing the size. By default, it's 640 by 480, but we are increasing it to 1280 by 720. So that is the idea. And then we are going to write while true, we are going to write success image is equals to cap dot read, and then cv2.imshow image and img, and then cv2.wait key. Now, I don't know if I mentioned this before or not. These images will be available on the website. So you can go ahead and download it from there. All you have to do is sign up and you will have access to these images. Now, you will also have access to the complete code, but I highly recommend that you follow along with the video, write it step by step. The reason I share the code is so that if you are facing any issues, you can compare with my code as well, which is available online. Okay, so let's run this and see if it works. There you go. So you can see me now. Now I have decreased the brightness a little bit over here so that you are able to tell the difference between PNG and JPG, because if it's very bright, we have bright images. So it will be a little bit hard to see if it's actually working or not. So this is the reason I have made it a little bit dark, but I think it's fine. So let's go ahead, and I'm not using a wide angle camera this time. Normally I use a wide angle camera, which is almost 120 degrees. This one I believe is 90, I guess. So it will not show you the complete room. It will be a little bit smaller, a little bit zoomed in. Anyways, so let's go ahead, and the first thing we are going to do is to add our hand tracker module. So we will write here from CVZone, CVZone dot hand tracking module import hand tracker, hand detector. So we are going to add our hand detector, and the first thing we will do is we will write down here detector is equals to hand detector. And do we need to we can write the minimum confidence required, let's say 0.75 or let's say 0.65. So if we want it to be more accurate, then we need to increase it so that it is a little more sure before it detects it as a hand. So now here is the part that is different in our new version, which is finding the hands. So earlier we used to write find hands, and then we used to write find position to get the landmarks. But this time around we will only write find hands, and that will give us all the information that we need. So here we will write detector dot find hands, and we are going to give in our image. And then here we are going to get back our hands, and we will also get back our image because we are drawing. It is on by default. If you want to turn it off, you turn it off by writing draw is equals to false, and then you remove the image. That's how you do that. But we will not do that. So let's go ahead and run it and see if we are getting our hand. So this is my left hand. It is detecting it properly. This is my right hand, and that's good. But if you have seen the previous virtual drag and drop tutorial, which we did with rectangles, it's a little bit difficult because left here is right, right here is left. So it's a little bit difficult to drag. So we are going to flip our image. So we will write here image is equals to CV2 dot flip. And we are going to write image, and the axis or the flip code we are going to write as 1. Now this will give you a problem. It will detect the left as right and right as left. So here we have to write flip type is equals to false. So earlier it was flipping, but now we have reversed it by writing here. So we need to reverse this as well. It's not compulsory for this tutorial because we are not using the left or the right in any case, but it's good to know. This is how you do it. So this is my right hand and this is my left hand. If I didn't flip it, it would classify it wrong. The left as right and right as left. Okay, so the next step will be to add our image to our main image, which is the image. That's a weird sentence. We need to add our image from one of these folders. Any image, we can grab it, and we have to place it on our main image, which is the camera, the image coming from the webcam. So what we will do is we will simply write the slicing method. So what is slicing? It's basically we write the image, and here we are going to write how much do you want to slice and what image are you going to slice it with. So we need to first introduce an image. So we are going to write here, let's say image1 is equals to cv2 dot imread, and we are going to read from images jpg slash, let's say 1.jpg. So we are going to add that image and we are going to put it here. Now, what is the size of this image? We can find it from here, image 1.shape, and we want to store it in height, width, and channels. Or you can ignore the last one. You can write underscore and it will ignore. So now, based on this information, we just need to give it a starting point. So we can define it here. Let's say my origin point, origin x, ox means origin x, and origin y is equals to, let's say 200 and 200. So this is my starting point. So I will say put my image at ox. I think y is earlier. So oy. So put my image at oy and then oy plus height. Then this should be colon, and then put my image at ox and then ox plus w. So this will overlay our image. So now if I wanted to change the location of my image, I will just change the number here and it will do all the calculation and it will put it there. So let's try that. So there we have it. So now you can see that we have our image, and if I wanted to move it, I can, let's say, push it further on the x-axis, let's say 500. So let's try that. So now you can see it is moving forward. So this is the basic idea, and what we need to do is that we need to check when are we clicking, when our finger is close to our region, when are we clicking, and when are we dragging. So once we know that and we do it on one image, then we are going to replicate that and apply it on multiple images. So this is what we are going to do. So how can we do that? Now it is very simple, and it is fairly the same method that we used earlier in the previous virtual drag and drop. So, but we will write it again so that it is easy to follow. So the first thing we will do is we will check if we have any hands. So we are going to write if hands, and now this hands is basically a list of hands. So we need to find the first hand. So we are going to find the first hand, and then from that hand we are going to get the list of the points, so the landmarks. So we will write here lm list. This L needs to be capital. So this will give us the lm list, and we will simply store it in the variable lm list. So now this is a list of all the landmarks, and we can simply get the information of each of our joints. So what exactly are we trying to find? We need to find what is the distance between our fingers, and we need to check if our index finger is in between the image region. So how can we do that? Now the image region is basically OX. This is the starting point of the image, origin point, and then it is OX plus width. So this is basically for the W or the x-axis, the width. And then we have the range of our image. For the y-axis we have OY, and then we have OY plus height. Now we need to check whether our index finger is in between these regions. So what is our index finger? Let's call it cursor. So we will say cursor is equals to lm list at point number 8. Point number 8 is the tip of the index finger, so we are going to use that. So we will simply write here cursor 0, which will give us x, and cursor 1, which will give us y. So this statement is checking if the cursor 0, if our finger is in between these x region, and if our cursor is in between this y region. If that is so, we are going to print, let's print inside. Oh, what happened? Let's print inside image. And let's format it a little bit. Okay, there you go. So let's run that. So now if I have my index finger, this is outside. If I bring it in, you will see it says inside. Doesn't matter which hand, I can do it with this hand as well. It's just the first hand it sees, it will use that. So again, we can put it inside, it will say inside image, outside image, and that's the basic idea. Now this is good, but now we need to drag it. So what we need to check is whether we are clicking or not. How do we click? We are going to click using our index finger and the middle finger. So we will be clicking like this. So this is a click. So whenever we click and then we drag, then it should drag. So we need to find the distance between these two tips, this and this. So index and the middle finger, we need to find the distance between these. And again, we have a very simple function for that. We can use that within our CVZone package, and it is simply find distance. So we are going to write here detector.find distance, and we are going to give in the points between which we want to find the distance. So the first point is basically LM list at point number 8, and the second point is LM list at point number 12. Number 12 is the tip of the middle finger. So we are finding the distance between these two, and we wanted to draw it on our image. So we are going to get back our image, and we want the length, length, and the info and the image. So these are the things that will be returned from this find distance method. So now it should draw, and we can simply print the length. So we can remove this print, and we can simply write here pass, just for now. So we are going to get our length. So if we do this, you can see it is giving us our length, and we will give it a point that we will give it a threshold that if it is less than that, then it means it is clicked. So right now I can see here it is 50-ish. I have to go back if I want smaller values, but I'm comfortable here. So yeah, I'm going to say 60. If the length is less than 60. Okay, so now we have our 60 value, and what we will do is we will say that if the length is less than 60, then it means it has clicked. And if it has clicked, then we are going to write the value of the cursor is equals to the LM list at 8. Okay, so this will be the value of the cursor. So this is what we are doing inside. We are not doing this outside. That's the first step. Check if clicked, and then check if in region. So first we will check if it is clicking, then we will check where did it click. If it's within the region, then it means we need to move. Now, how exactly do we move? Moving actually might sound complicated, but it's not. It's very easy. All we have to do is we have to update the value of OX, and that's pretty much it. So what we can do is we can write here OX and OY is equals to our cursor 0 minus the width divided by 2, because this is the starting point and we want the image to be in the middle of our finger. So that's why we are doing this. Otherwise, we could simply write the cursor 0 and the cursor 1. But we don't want it to start from the edge. We don't want our index finger to be at the edge. We want it to be in the middle of the finger, of the image. So here we will write cursor at 1 minus height divided by 2. So this is to make sure it is a whole number, because we are working with pixels and we cannot afford floating values. So let's run that, and hopefully this time when I click and I move, it should move as well. So let's click, and there you go. It's very smooth. It's nice. Can move it around. Okay, when it goes down, it's a little bit tricky. I need to go back a little bit. Yeah, now it's fine. So this is basically the idea of these images, how you can import them. But now the main thing is that we only have a single image. What we want to do is, first of all, we want to include JPG images and PNG images. But how do we include a PNG image? Let's have a look at that. So the procedure will be pretty much similar to this. So we will write here that this is for JPG images, draw for JPG images, and then we will have draw for PNG images. Now, the main difference here is we want the transparency, so that's why we have a separate section for it. So how exactly can you do that? Now, we have a very simple function to do this. All we have to do is we have to write CVZone. CVZone is not included, so we'll write here import CVZone, and then we will go down and we'll write CVZone dot overlay PNG. Now this will overlay the PNG on an image, but which image you want to overlay it on, we will write image, and which image are you overlaying it with. So this is the image back and this is the image front. So the image front is basically image 1. And then we have to give in the position. So the position you can give 0, 0 by default, but here in this case we need to give OX and OY. So this is our origin points. So again, this is origin, this is not the center point. The overlay function uses the origin, not the center point. Okay, so this is good. What we can do is we can remove this part and we can run it, and hopefully there won't be any issues. No, there is a problem. The problem is that when you are importing, first of all, we didn't change it to PNG. I don't know why I'm hurrying so much. So we need to remove that. And what we'll do is we will copy that, paste it here, remove that image, and instead of JPG, we will get PNG, and we will write 1.png. Same image with the car. But this time around, when we are importing PNG and we want to check the transparency, or we want to use the transparency, we need to write here cv2.unchanged. IamRead unchanged. So we have to write that. So once that is done, now we should be able to run this function. So let's go ahead and try that out. Nothing happened. If I bring in my image, hand, nothing. Okay, so we need to find out where exactly is the issue and why is this happening. So here, overlay image. Oh yeah, my bad. See, this is why we should not hurry. So we need to return it to our original image, and that's why it's not showing. And there you go. So now the beautiful thing is that if I click on it, I can drag it around, and it's a car with, okay, what's the issue? Oh yeah, so you have to be careful not to take it outside of the parameter. Now, if you don't want to get this error whenever you're going out, then you can simply write here, try, and then accept. This is a lazy way of doing it. You can write your fancy algorithms to fix that and show half of the image and all of that stuff. But for now, we are just going to write accept pass. So I'm going to push that in, and there you go. So now if I have, even if I go out, it will not show me, but it will at least not give me an error. So this is basically the idea. I can very easily drag it around. And this will be very fun game to play with. I'm thinking of the game. Maybe in the next video we can try out, especially for kids. They have to concentrate and move very slowly and then place it somewhere. There's a game operation. Maybe we can play that with this. So it will be fun to see the application. But wait, we are not done yet. We need to put this so that we need to write the code in object-oriented programming method so that we are able to add multiple images, not just one image. So what we will do is we will just give in the name of the folder, and once it imports that folder, it will take in all the images. Whether it's JPG, whether it's PNG, it doesn't matter. It will grab all the images and it will overlay them in the appropriate manner. So how can we do that? This is very interesting. So don't leave just yet, and we are going to see how it can be done. Okay, so the first thing is that we are importing one image. So we need to fix that. We need to import multiple images. And whenever we are importing, we need to check whether it's a PNG or whether it's a JPG. And based on that, either we will write it like this, or we can write it like this, based on what type of read are we doing. So if it's PNG or if it's not. So the first thing we need is the OS. So we will write here import OS, and down here we are going to find out the list of images that we have within a particular folder. So let's say our path is equals to images PNG. Let's start with PNG. Let's put it in quotation. There you go. So let's say this is our path and we want to find out all the images that are within this. Let's remove the prints because we are about to print. Any other print? No. Okay, so what we will do is we are going to write here my list is equals to os.list directory, and we are going to give in our path. So what we will do is we will write here print, and we will write here my list. So if I run this, it should give me 1.png to, yeah, there you go. So it's giving me 1.png, 2.png, 3 and 4. So I can use this information to import all the images. So what we will do after importing, we are going to put it in a list. So we will write here list image is equals to empty. And now we need a loop to go through all these names of these images and import them. So we are going to write here for path image in what do you call path, not path, my list, or was it called? Yeah, my list. So we are going to get that, and what we will do is we are going to import our images. But here is the tricky part. We are not just going to import our image here. What we will do is we will create an object. We are going to create a class, and from this class we are going to create multiple objects. So each image is basically an object which will have its own size, it will have its own pixel values, it will have its own origin position, so we can update it as we go along. So it will be easy. Now you can do this with lists, with functional programming, but it is a little bit harder to do with that. It is not very efficient. So that's why we are going to use object-oriented programming. So how can we do that? Again, I will go step by step, so it will be very easy to follow. So what we will do is we will write here a class, and we will write here drag, not frag, drag image. And then we are going to write the first initialization method, which is init. We always write this. And then what exactly do we need? To initialize an image, we need the path for it. So that's the first thing, we need the path. We need the origin position. Where do you want to put it, right? So we will write here position, let's say origin. And then the third thing, which is very interesting, is we need the type of the image. It can be PNG or it can be JPG. If you want to add more, you can add it later, but these are the two that we are going to use for now. So this is the image type that we are going to use. So what we will do is, whenever we create an object, we are going to give these values and store them. So it will be self dot position origin. If you are not familiar with object-oriented programming, I highly recommend that you check out a tutorial before you actually go through this, because it will be a little bit confusing. So what we are doing is we are setting the values for each of these objects, and then we are going to write self dot image type is equals to image type, and what else? The path, yes. Now for the path, we are going to check if the type is PNG, then we are going to import it with IAMRead unchanged. If it is not, then we are going to import it like this. So we will write here if self dot image type is equals to PNG, then we are going to write here that our self dot image, this is the new image that we are creating, image is equals to CV2 dot IAMRead images and IAMRead unchanged. So this is the path, so we need to change it to self dot path. So this is basically the idea. And did we define the path here? No, not yet. So here we need to write here self dot path is equals to paths. So we need to define that. So that will come here, and if it is not the case, in any other case, whether it's JPG or other images, then we are simply going to write it like this. So instead of image, we are going to write self image and IAMRead, and here we are going to change it with our path. So again, the only difference is basically this IAMRead unchanged. So if it's PNG, you import it like this. If it's not, you import it like this. So that's basically the idea. And once we import, we are also going to add another parameter, self.size. So we are going to write that, and we will write self.size is basically self.image, the image that we imported, and the shape of it. The shape. Now the shape will give you three things: height, width, and channel. So you can simply write it like this. So this basically means give us the first two parameters and ignore the rest. So it will ignore the channel. Otherwise, you can also write it like this. You can write it like this, and then you can write it like this. So you can see it's very long, so we will remove that. Okay, so this is the idea. This is the initialization. So that is done for the moment. And now what we can do is we can go to our for loop where we are creating our new images. What we will do is, first of all, we will check to add a new image, we will only write drag image and then all these parameters, right? So we will write here drag image, and within that we have the path. So path is our path of our image, but this path is like this, 2.png. We don't want just that. We want it images png / 1.png. So we have to write an f string here. So we will write here path, then we will write slash, then we will write path image. So this will give it path, which is images.png, images png slash, this is the slash, then path image will be, let's say, 1.png. So this will create that complete path. Then the second parameter is basically, what happened here? Why is, oh yeah, we didn't finish it. Okay. So what is the second parameter? The second parameter is the origin. So the origin, we can, let's say, give it 100 and 100 for now. I'm just going to do it with one image and then we will do it later on with more images. So 100, 100 and 100, and then the last one is image type. So here we know that the image type is PNG. So I can simply write here PNG for now. So this is good, but the issue is that we need to automate this to check whether it's PNG or not. So what we can do is we can simply write here an if statement. We already have this path image, which tells us the extension. So if it is PNG, we can check here if PNG in path image, then let's say image type is equals to PNG, else image type is equals to JPG. So this is the idea. If we have PNG in this string, then this image type should be PNG, otherwise image type is JPG. So we will copy this image type and we will paste it here. So now if it's a PNG, it will show PNG. If it's a JPG, it will show JPG. So in order to see if it works properly, what we will do is we will go to this folder and we are going to open it up. And here we are going to write a new folder, images mix. So here we will have two of the JPGs. So 1 and 3, let's say, is JPG, and PNG is 2 and 4. So this way we will have both. So now instead of images PNG, we will write here images mix. So what we will do is here we are adding all the images, but we are creating these objects, but we are not doing anything with it. So we will write here that our list of images dot append, and we want to append it with this object. So this is basically the idea. So we are appending that, and now what we can do is we can print, let's say, the list of IMG, and we can print the length of it to see if we are importing 4 images or not. So let's run that. We are getting an error. What did I name it? Image mix. Oh, I renamed it wrong. We need to change it to images. I want to keep it consistent. So we will write here images mix. So let's run that. And there you go. So we are importing 4 images. So that is good. But do we know if it's PNG or JPG? We can write here. If it's PNG, print PNG, else print JPG. So we will remove this print. So now it should print PNG, then JPG, then PNG, then JPG. Or I think the first one was JPG. Yeah. So JPG, PNG, JPG, PNG. So it means it is importing properly. So that is good. So again, we can go back to just one image, as I mentioned before. Or should we do all of them? Okay, let's just do all of them. It should not be that hard because we're already writing the code. So now we are getting all these images from our folder, and it has been stored in images list. And all these objects have been created from this class. Now the next step is basically to update our images, and we need to draw them. So first of all, what we will do is, instead of drawing just one image that we have imported, we are going to draw all the images. Why is it still there? We need to remove this. We will remove this and we will remove this. So we need to draw all the images. So here in the draw for JPG, we are going to write Let's say this is for all draw. So we will write for image 1, or let's call it image small, instead of saying 1. For image small in list of images, what do we need? First, we need to change this equation now based on this. So image S is basically not an image. It is an object. Okay, let's write it as an object so you are not confused. So this is an image object. So within this object, we have the actual image, we have its origin, we have its type, we have its path, we have its size. All of this information is within that. So we will write here, instead of image 1, now it will be image object. Image object dot size. That will give us the width and the height. So it doesn't have 3 parameters. If you remember, we removed the channel from here. So it has only height and width. So we can change that. Now this equation is ready. Then we have this equation. So now, should we run this? We need to check the type first. So we will write here, if our image object dot image type is equals to PNG, we need to put it in quotations, then we are going to do this, draw PNG, else we are going to do this. So I hope that is clear. Now we need to change the values over here. So the first thing we need to change is the image 1. So image 1 will be image objects dot image. Simple as that. And here again, image objects dot image. So this will be our image. And then we have OX and OY. So this is the position, the origin position. So this is not just OX and OY, it is coming from the object itself. So we need to write it here. We can write it here simply, that OX and OY is equals to image object dot position origin. So that will give us OX and OY. So now, whether it's a PNG or JPG, it will draw whatever it is. So that's our first part. So let's run that. Yeah, so it is drawing all of them, but all of them are at the same location. So what we need to do is we need to put it forward and we need to change the X location. So every time we are creating an image, we are getting it and importing it, we are setting the position of it. So what we need to do is we need to set a variable here. So what we will do is we will write here, we need to count how many images did we add. So we can count it by adding an enumerator here. So enumerate, and we will write here X, and that X will be the count. So we can say X multiplied by, what is the size of these images? 225. So if it's 225, let's say 300. So we'll multiply it by 300, and let's say the height is 50. And we can give it an initial push. So it's not starting from width 0. So it is starting from, let's say, 50. That is the initial push. So now it will draw them side by side. So there you go. So the first one is JPG, second one is PNG, third one is JPG, fourth one is PNG. Now if I do anything, nothing will happen, because each of these images need to update in real time, and we are not doing anything to update them. So what we have to do is we have to create a method in our drag image that will update the position of this, position origin. So how can we do that? So we'll write here def, and what do we call it? We will call it update. That's simple. And if we are updating, we need the cursor value. If you remember, when we are updating it, when we are checking if it's in the region, we are checking based on the cursor value. So we need that cursor value. So that is the only thing that we will be requiring. And after that, we will take the code from here. Let's cut it from here and we will paste it here. So where did the other part? Okay, it's copied. So now what we need to do is we need to run this equation, but we have some errors. So we need to find these variables. So OX and OY, what are these? These are basically the position origin. So we can simply write here OX and OY is equals to self dot, what am I doing? Self dot position origin. So that error should be gone. Then we need the cursor. The cursor is already there. We have the cursor and width and height. So width and height basically are width and height is equals to self dot size. Okay, so that should be it. Or is it the other way around? Yeah, it is the other way around. Height and width, my bad. So this is the idea, and yeah, that should be it. And then once we are updating it, we need to update the position over here. We need to update the position of this object. So we will write here, instead of OX and OY, we will write here self dot position origin is equals to this. So this is the updated value. So this is value 1, this is value 2. So now we need to call this update function whenever we are within that click range. So if we are clicking, then we will write, we are going to loop through all the images because we have a lot of images. So we will write here for image objects in, what was the name? List image. We are going to iterate, and then we are going to write image object dot update, and what we want to update based on the cursor. So that should be it. Let's see if that works. So let me check one more time. Yeah, it seems fine to me. Let's see if it works. So there you go. So I can move this around. Let me go a little bit back. There you go. I can move the PNG image. I can move the car. I can move the clock, and I can move the globe. Ta-da. So this is how basically you can move these images around. And the best part here now is that all I need is a folder. So no matter how many images I have, I can just put the images in the folder and it will work. But again, if you want to put it in different rows, then you will have to add some code to that. I did not do that yet, but if you wanted to, you could do that. So now to test it, what we can do is, instead of images mix, we are going to write images PNG. So all of them will now be PNG images instead of JPG. So there you go. These are all PNG images. I can drag, I can move it around. And to be honest, it is quite good. It is quite smooth. But again, if you go out of the region, it will flicker, it will disappear. So you can add some code to that to fix that issue. But I think this is quite good. And it is not slow at all. It is, it's not real time, but still it is not that bad. There you go. See? Okay, so then we are going to try it with JPG images. Let's go ahead and try that. There you go. All our wait, what happened here? Why is it showing mix? Did I make a mistake somewhere? Yeah. I think I copied it maybe in the wrong place. Okay, let me fix the folder, images JPG folder. Okay, so now I have fixed the JPG images. So we should be able to see, yeah. So you can see all the backgrounds, they are white now. These are JPG images and I can move them around. There you go. So this is basically the idea how you can add images. And if I removed one of them, let's say I don't want to delete it. Let's try the PNG again. PNG. And let's say I remove one of the image 4. I push it outside. And if I run it again, now I will have 3 images. So this will automatically detect how many images you have and it will paste them. So that is basically the idea. Again, if I'm going out, it will disappear. All of these images will disappear. So you have to be careful, or you can add your code to fix that issue. Or later on, maybe even when I'm creating a game, I might add this part. So this is basically the idea of today's tutorial. I hope you have learned something new. This is quite exciting because now we are heading on to something that might actually be useful in games or in actual applications. We are virtually moving our hand to control different things on our computer, and it is quite fast and responsive, and it can be useful in a lot of different applications. So this is it for today's video. I hope you have learned something new. If you did, share it with your friends. If you liked it, if you loved it, leave a like below, and do share your views and your ideas in the comments below, and I will go through them, and hopefully we will create some projects that you have shared and you have suggested. So this is it for today, and I will see you in the next one.